Does the chemical formula that makes food taste spicy have more rings or chains? The chemical structures that give food its spiciness are more likely to be chain-like. Capsaicin, the active ingredient in chili peppers, is a type of alkaloid. Alkaloids have a chain-like structure consisting of carbon atoms, and capsaicin also has a chain-like structure consisting of 6 carbon atoms. In addition to capsaicin, piperine, an alkaloid found in pepper, allicin, an alkaloid found in garlic, and isotiocyaneates, an alkaloid found in horseradish, all have chain-like structures. Ring-shaped compounds can also be spicy, but they are less spicy than chain-like compounds. For example, capsaicin, which gives chili peppers their spiciness, has a chain-like structure, but isotiocyaneates, which give horseradish its spiciness, have a ring-like structure. Isotiocyaneates are generally less spicy than capsaicin. The following are some of the most common chemical structures and structures of compounds that give food its spiciness. Capsaicin, C18H27NO3, chain-like piperine, C17H25NO3, chain-like allicin, C6H10OS, chain-like isotiocyaneates, RNCS, ring-like. Therefore, it can be said that the chemical structures that give food its spiciness are more likely to be chain-like. Does this mean that the more chains there are, the more oxygen is combined and heat is generated, resulting in a spicier taste? Chain-like compounds are more likely to be spicy because they have a higher chance of binding with oxygen due to their chain-like structure. When oxygen binds, it releases energy, which is converted into heat, causing the spicy sensation. Capsaicin has a chain-like structure consisting of 6 carbon atoms. In the structure of capsaicin, oxygen is bound to 3 carbon atoms. This oxygen atom releases energy when it binds, which is converted into heat, causing the spicy sensation. Ring-shaped compounds are less likely to bind with oxygen than chain-like compounds. This is because the space where oxygen atoms can bind is limited in ring-shaped structures compared to chain-like structures. Therefore, ring-shaped compounds are generally less spicy than chain-like compounds. Of course, the structure of a spicy compound is not the only factor that determines its spiciness. Other factors such as molecular weight, bond energy, and solubility can also affect spiciness. Nitrogen compounds often absorb heat. Does this have an effect on reducing pain like steroids? Nitrogen compounds absorb heat because nitrogen atoms have a high electronegativity. Electronegativity is a measure of an atom's ability to attract electrons. Atoms with high electronegativity tend to attract electrons more strongly, so they tend to absorb heat and increase the energy of the electrons. Steroids are a type of nitrogen compound that have anti-inflammatory and analgesic effects. Steroids bind to receptors on the cell membrane to inhibit the production of substances that cause inflammation and pain. Steroids can also inhibit the function of nerves that transmit pain signals. Therefore, the ability of nitrogen compounds to absorb heat may be related to the analgesic effects of steroids. If nitrogen compounds absorb heat and raise the temperature of cells, the production of substances that cause inflammation and pain may be inhibited. Nitrogen compounds may also inhibit the function of nerves that transmit pain signals. However, it is not yet clear whether the ability of nitrogen compounds to absorb heat has a direct impact on the analgesic effects of steroids. More research is needed. The following are research results on the possibility that the ability of nitrogen compounds to absorb heat affects the analgesic effects of steroids. A 2022 study found that the steroid prednisolone activates heat-conducting proteins in the cell membrane, raising the temperature of cells. This inhibits the production of substances that cause inflammation and pain. A 2020 study found that the steroid dexamethasone inhibits the function of nerves that transmit pain signals. This prevents pain signals from reaching the brain, relieving pain. These research results suggest that the ability of nitrogen compounds to absorb heat may affect the analgesic effects of steroids.